Hey everybody, Javan Bernakevitch here with All Points Design. That's allpointsdesign.ca and Neil Bertrando. We've done a lot of these. This is the only moment I get to play of RT Permaculture. Today we're talking about the Oregon State University Permaculture Design course, and we're talking about Assignment 7. We're talking about the soil jar shake test. Now, the soil jar shake test is one of the first interactive observations we're going to have with this site. We're going to go in, we're going to take a soil sample, we're going to put it into a jar, we're going to add potentially a little bit of soap to reduce the coefficient of friction, we're going to shake it up real good, we're going to set it down, we're going to let it settle out. Now, you've already seen the assignments, you've already seen the video, so you know that things like sand are going to settle out very quickly, silt less so, clay very much less so, especially if you have very dispersive clay. It can take upwards of 30 days. So if you don't have a clear read on your jar, make sure you set it down in a place where you can leave it for upwards of 30 days to come back and make sure that the general or the gross observations you have of this jar are true in the long format. The other thing that Neil and I both find is very true is to take multiple tests within your site, especially if there's a big topographical change or if there's a big microclimate change. Good to get a sense of what the soil looks like on multiple areas of your site. We're going to be showing you a couple of examples today, but before I start, Neil, is there any specifics you wanted to pass on to people about the soil shake jar test?
So yes, we're estimating soil texture. That's the reason for the test. I think that's important. And I recommend you use a quart-sized jar, and something that a taller jar is better than a shorter one, because what we're looking at is the settling of sediment and the sorting of sediment by settling, and the sizes are sorted through that. So a long column of water gives a cleaner and better resolution of that settling. Also, make sure that you fill your jar up enough with water, and leave a little air gap at the top to give you a good shake, but fill it near the top with water, and only about halfway or 2/3 of the way with soil, because if it's too full of soil, the particles get in the way and they don't sort appropriately when they settle, so you won't get a clean read on your soil.
Great, thanks, Neil. Okay, let's take a look at a couple examples here. So starting off, we've got a site map, and they've shown us exactly where the soil is coming from. This is a great place to start. It tells us what's happening, where this is taken from, and usually why. So site of soil testing and region being evaluated for expansion of plantings. Great, I know why you're doing it. Optimum sun, drainage, and wind. Fantastic. Soil analysis needs to anticipate root depth. So they took a look at the annual root zone of 12 inches. So they took a look at the O horizon, or the organics layer, and the A horizon. Perennial root zone up to 48 inches, taking a look at O, A, and B. So taking a look at all of these strata. Really great to start off already, giving us a sense of what's happening, where the piece is coming from. As we take a look, they did a spade. They took a spade and then gave us a sense of what the crosscut was looking like. They took a look at the O horizon of the sod. They took a look at the A horizon of the topsoil. Take a look at the B horizon, dense, less organic matter and microfauna, and then started to take a look a little bit at the C horizon of the substratum. So great to see they put some great examples of the sizing, and the distance, and the depth here. So we got a sense of what was happening. Pointed out a few things that were of interest, like the earthworm, a couple of differences in terms of less organic matter and microfauna, where you start to get the parent material starting to mix with the soil. So great to see the horizons on here. And then they got to the test themselves. So took a look at the A horizon and the B horizon. Said that it test jar at 30 minutes, 2 hours, and 48 hours. So took a look at these 3 different levels, gave us a great picture of the soil. Now, this isn't part of your assignment, but it should be. It's great for us to take a look at the coloration, the gradation, how the soil beds are being formed. And then, as Neil was talking about, getting a clear photo of the jars. Now, I would say that in both of these, not enough soil was placed into the jar. We could have gone up probably halfway here. Also, when you're using a rounded jar edge, the results are slightly skewed. So if you can, try and find a glass jar that comes down and has a square bottom. Now, some people are going to get confused by that because, of course, the jar is circular. But when you tip it up, instead of being rounded as we see here on what looks like salsa jars, so we've got this rounded edge. If you take a look like an Adams peanut butter jar, you have a really square edge to it. And that gives us a more accurate reading. Took a look at the organic matter. And again, organic matter is not included in the total percentage of the soil texture triangle. We're only taking a look at clay, sand, and silt. This is something that a lot of people get confused on. Minimal clay in suspension, I would say that's generally true if this was taken at the 48 hours. Less than 5% clay, 30% silt, 70% coarse sand and gravel. Went over and took a look at the clay. So going up on the clay level, here's 10, here's 5, less than 5, so we're in this category. 30% silt, so then going down to 30, coming in. And now the great thing about the triangle is you actually only need 2, because if your numbers are correct, it will result in the last final 70%. So again, we're right in the money. So that last number is actually a check and balance for the first 2. Taking a look at the B horizon, 5% clay, 25% silt, 70% fine sand, very similar. So 5% clay right on the line, 25% silt, 20, 35 right on there. So we would say it'd be 70. There's our check and balance. So what we need to see is we need a clear photo of the jar. And these photos aren't bad. They were done at night, obviously. They were done with a flashlight. You can take them outside in daylight. It's the best light you can use almost. But if you have to do it inside, make sure you get a lot of light on it so it's very clear. I would also say that this jar was probably not set down perfectly flat, because you got a little high side there. So they probably shook it really well and then placed it and it kind of shifted over. So yeah, there's no longer any tea in my cup. So when you are shaking it, you really want to shake and then set down. If you do sort of a slow set down, you'll find that you'll get a bunch of material on the side that's on its side as you're setting down. Neil?
Okay, I really like that they showed the soil profile and the location of the test on their map. Those are 2 things that often aren't done. I don't know if they're really clarified in the assignment instructions, but these are really valuable things for you to integrate and learn about your site. So it's not unlikely, if you have a site of any decent size, that you're going to have different soil profiles and different soil types on your site. If possible, I recommend doing a soil texture test for each soil type. And then within your soil profile, it's important not to mix horizons when you're doing your soil texture test, because this won't give you an accurate test of the soil texture that the vegetation is actually experiencing on the site. And if you're planning to do any sort of earth moving or using your soil resources for engineering, building, any sort of thing like that, you want to have an idea about the different depths and types of soil textures that you have in each horizon, so you can get an idea about volumes and or other things that are important to the design process and the actual development and use process of the site. It would be ideal to see a ruler in these, something for scale that shows you actually the size, both on the jar and the soil profile. So I'd like to see a ruler there if possible. Just put it right next to it and take a photo with it there, tape it to the jar if you need to. Also, as Javan mentioned, making that soil depth in the jar, at least half the jar, half to 2/3. Right there is where you want to be. Half is good. If you just go straight for half, you'll be right on every time. Because when the soil depth is really short in the jar, any error in measurement gets magnified out in the math that you're doing, because you're going to be dividing and multiplying the heights into the total. So if you have a bigger total height, you get a better measurement and you're less likely to have error. And little errors in measurement in a height like this, which is maybe an inch, a couple of centimeters, translate into potentially large errors in percentages when you multiply it out, and could move you into a whole different texture. So it's definitely worth getting a taller jar and filling it half full.
Awesome. Thanks, Neil. Those are great points. All right, we're going to take a look at one more example, maybe 2. We'll take a look at one with a ruler just to give us a sense of what that looks like. So here we've got an example that gives us a sense of A ruler gives us a sense of the jar taken outside, very clear. Obviously, the clay was very specific. And then also got a second sample and a third sample, and they gave us sample locations. So lots of great elements here that I appreciated. Nice to see where those elements were coming from. Now, one of the things that I found interesting is they took sample A and sample B, same location, but at a depth of 14 inches. So again, trying to get a sense of what those horizons are, as Neil was talking about. And I think that is it. Those are the differences from the other one. Neil?
So I usually, when you're digging a hole, you will see a difference, a color difference, or feel a difference when you're digging, when you come to a different horizon layer. If you don't, if there's not a clear, distinct difference, then don't take two different samples. So you should be able to see or feel that difference. If not, and it's really subtle, then I would say just a single sample is good. I also want to recommend, I'm going to share my screen really quick.
Please.
Okay, I'm gonna, so. Okay, are you looking at the Colorado State Estimating Soil Texture document?
I'm not.
Okay, because I didn't share it. Now you are.
There we go.
So this is the document that I recommend you follow. I find it's very clear. It goes through, it actually describes what the different textures are, and it gives you their sizes, the soil triangle, the field test, which we'll come back to. I recommend you do a soil texture by field test with a flow chart. Let's see, keep going down. Lots of information, but most importantly, it gives you a data sheet, which clearly walks you through step by step, gives you places to write down your specific observations, and it gives you a specific time for each soil texture type, which is really valuable if you have soil textures that the particles look similar. If you can't easily tell by eye the difference, I really recommend you just use the time on your first one. After a minute, mark the location on the jar, the depth of the sand. I do this with a fine tip marker. And then after 2 hours, mark the depth of the silt. When the water clears, typically takes 1 to 3 days, mark the level of clay on the jar. So you want to make sure you get ahead of the game on this and do this a little bit early, because clay, especially if clay soil, it can take quite a while to settle out. So I recommend using this one and following this data sheet. You have it all in one place, and it's very clear, so you don't have any questions about how to do it. Okay, and then let me unshare my screen, and we can go back to stop share. There we go. Back to the assignment.
Awesome. And I'm just going to share one more before we go into soil texture by field. So again, this is a great example, gives us a sense on the base map. Now, they ended up printing their base map, taking a photo of it, and then giving us a marker. Easy. Like, it shows how many different levels of interactions you can have with your map. You can draw, you can take photos of it, you can work with it again. So great example here. Gave us a sense of what the soil looked like. Gave us a good example of the jar. We're missing the ruler here, which I would have liked to see, but does gives us the percentage of what was going on. Now, if anybody can catch what's wrong here, we started to put the percentage of water in here. Again, this is just the percentage of clay, sand, and silt. So from the top of the soil within the jar to the bottom is 100%, and then we're splitting that up into 3. We're saying how much clay, how much silt, and how much sand. This person has changed it up with fine sand and coarse sand because the soil texture calculator they used has that delineation. But in terms of the resolution we're looking for in this course, you only need to do just sand, silt, and clay. Anything else about this one or finishing up, Neil?
Well, I think, yeah, just the graphic communication of that, where they have organic material, 3% water. It's like not clear what the percentage is even.
Mm-hmm.
So make sure that those things stay on the same line, or easy to tell the difference between, both for communication to us as well as for your own records. Yeah, so soil texture is just the physical particles. It doesn't include the biological fraction. It doesn't include, so the organic material or any living material. It doesn't include water, and it doesn't include air. All those are parts of an overall soil, but the soil texture is just the geological sediment fraction, the clay, the silt, and the sand.
Okay, folks, so we're going to take a look at something that is not necessarily in the assignment, but both Neil and I highly recommend you do this at least once or twice within the samples that you have. So you've got the jar, you've shaken it, you've gotten a sense of the percentages, and you've got a sense of the soil type within the soil texture triangle. That's great, that's awesome. Chances are that you have a jar in the field all the time is very low, and you usually don't have the time to actually let it settle out. So something that both Neil and I do is we do a soil texture by feel test. And again, that document that Neil shared of the Colorado determining soil texture by feel is a great one. You'll see these flow charts all over the internet, and they're always the same. What we're doing is we're taking soil and we're starting to give it a bit of water, building it into a ball, and then starting to let it soak up. And right there, we start to have our first delineation. Does this water allow the water to soak up, right? If no, then sand. A very simple dichotomous flow chart that moves from point to point to point to point. Does the soil remain in a ball when squeezed? No. Is the soil too dry? Yes. Place more water. No. Is the soil too wet? Add more soil. So every single point as you're going through here, it's got all the options for you. At this point, we place the ball of soil between thumb and forefinger and gently push it and squeezing it upward to create a ribbon. So does it form a ribbon? No. Loamy sand. And again, we're taking this information, we're comparing it to the soil texture triangle that we produced the results from with the soil shake jar test. Does soil make a weak ribbon less than 1 inch before breaking? No. Does it 1 to 2? No. Does it 1 to 3, right? As we go through this, we get a sense of the length of the soil that comes off. And then at that point, we decide, does it feel very gritty? Does it feel smooth? Is it neither gritty or smooth? So first we get a sense of how long the ribbon is, and then we're asking what's the grittiness of it. And then we start to classify ourselves into these different types of soil texture classifications. So this is not necessary, but you will find if you're my student, I will say you should absolutely do this in my comments, because we need to start to build a lot of hands and eye and feel, a lot of observational feel, a lot of sensory feeling and observations of a site, not just rely on things that take a little bit of instrumentation. But again, that instrumentation is not going to be the same everywhere you go in the world. When I was in Cuba, I couldn't find a glass jar. When I was in Africa, they had one, but it was the tiniest little glass jar you ever saw in your life. So while the glass jars are great for us to visually see and start to decode soil and texture, more often than not, this is the type of soil texture testing I'm doing in the field. Neil, did you have something you'd like to add about that?
Yeah, I totally agree. What we're working with you here on during most of this course is actually observation and analysis skills. So take the opportunity to practice, because you only develop a skill by doing it through repetition over and over in guided practice. And this has a nice, clear, dichotomous key flow chart, which allows you to practice in a very safe, contained space and just try it over and over again, and try it with several different soils. And developing your skills that you take with you anywhere you go, your tactile skills, your observation skills, are really valuable from both a permaculture design standpoint as well as just a general land assessment and reading the landscape standpoint. One thing that I'd like to throw in there just on that line is when I'm analyzing or investigating a site, usually what I like to do is I like to make an observation, then make an assessment. What does that observation mean? That's often a judgment. That's separate from my observation. And then from that, I might develop a treatment or a response. And so having those 3 layers, I think is very powerful and a good tool for you to think about when reading the landscape. What am I observing? What am I judging or deducing about that observation? And what response am I going to choose to do in response to that observation and judgment, and why?
Brilliant. And playing that into this conversation, let's say there's an area of your site that through observation you've assessed to be sandy, very sandy, let's say. Now the assessment of that might be, well, there's a few things that are going to grow well here. There's a few things that are not going to grow well here. And then as you start to overlap the client questionnaire, the microclimate, the zones, all on top of this, you're going to start to get a real clear picture of what's possible in this site. Not a lot of maintenance, okay? Not a lot of ability to create a watering plan, not a lot of budget for irrigation. Okay, well, now we've got a lot of things stacked up to, we can't necessarily change this soil or work to change the soil because we don't have the time or the resources. Great, so we might just plant things that would work in sandy soil instead of trying to take the energy to put the work into it. So that type of protocol, that idea of observation, analysis, and treatment is a really good one to think about, because while you're taking all these observations and learning, it's very easy, again, to get into that permaculture grocery store mentality, like, oh, just grab a treatment off the shelf and plunk it in. But the overlap and the intricacies of all these different assignments and points of observation really do constrain a design and give you a sense of what's possible and what's not. So thank you very much, Neil. I think that's a really important piece. All right, thanks so much, folks, for joining us for the soil shake jar test. I don't know why it went Sean Connery there, but it did. The soil shake jar test with the Oregon State University Permaculture Design Certificate. Okay, we only have a few more to go. Thanks so much for joining us. We hope to see you at the next video.